Bismillahirrahmanirrahim. Welcome to online chemistry class. And our topic tonight is alkene, right?
Yes, sir.
In the last class, we finished with alkanes,
Yep.
the homologous series of saturated hydrocarbons.
Yes.
Now we are going to start with a new homologous series.
Yes. Which
And
is alkenes.
absolutely right, alkenes they are. These are our learning objectives, which I wrote
Yep.
first.
What are alkenes? How are
abs-
they named?
Absolutely, we'll go
Functional group in alkenes. Making alkenes. Reactivity of alkenes. Chemical reaction of alkenes and isomerism in alkenes.
absolutely right. These are our learning objectives, which we'll try to cover, inshallah ta'ala. Maximum
Yes.
learning objectives we will try to cover.
Yes. Yes.
And before starting this class, as usual,
Yes.
you know what we used to do. We always start our
Yes.
class with the starter activity. So here we are
Yes.
with the starter activity. Please take
Yes.
your time and come up with the response. You need to write down a balanced
Yes.
chemical equation for the combustion of butane on the board.
Yep.
Your time starts now.
Yes.
I would like to
Balanced chemical.
I would like to mention it's a complete combustion, right?
Yep.
So you know very well how to write down the equations for the complete combustion of hydrocarbons, right?
Yes.
So please do it here.
Yes, sir. I'm doing.
Do it on the board, please. Directly you can write on the board, no issue at all.
Okay. So it will be.
And then you can balance the
Uh.
equation.
Yes. So it will be like this. Okay. C4 H10 plus
You're right. Please keep it up. That's good. Now you need
so
to now you
can
can
I write the long balance form that I did last
sorry.
time?
Now you can balance it.
Can I? Yeah.
And first
Okay.
of all, you
So
know how to balance the combustion equation. First of all, we balance carbon. So first
with
balance the carbon.
carbon.
Yes, please.
So if we have four carbons there, we need to
Absolutely.
have.
Yes.
So it will be 4CO.
Yes. Please write it here.
Yes, sir.
Then
And then we need to
balance hydrogen.
hydrogen. We have 10 there. So over here we need the 5
Absolutely. And finally, we balance oxygen, which is in excess.
oxygen. Yes. So we have over there 5 oxygen.
Yes,
So
please.
it will be wait. Yes, sir. Doing okay. 5. So it will be.
3O2.
Is that done, sir?
Wait, you wrote 3O2. Hello, right?
Yes, sir.
You wrote 3O2. It means 6 oxygen.
Yep.
Do you
No,
think,
no, that's wrong. Just
beta,
no, wait.
you can
I
count the
forgot.
oxygen here? We are having 8
Yes,
oxygen here, 5 oxygen. This one,
yes,
8,
13.
8 plus 5, it makes 13. So now they are
Yes,
double.
13.
They are 30, 13
Yes,
into 2, 26.
yes.
What we must do to make it 13?
We divide by 2.
Absolutely right. So do it accordingly then.
Done.
That's like a good boy. You must be very careful, dear, because
Yes, sir.
when we discussed a certain pattern for the balancing of combustion equations, you should not deviate from it, right?
Yes. Yep.
Any confusion?
No.
That's correct. Should we move ahead now?
Yes.
Now, we will look into the introduction of alkenes. How are they named? Functional group in
Yes.
alkenes, how the alkenes are
Yes.
made, and finally the reactivity in alkenes,
Yes.
right?
Yep.
Okay. So first of all, the introduction of alkenes.
Yes.
Alkenes are a homologous series of unsaturated hydrocarbons, right?
Yes.
I'm using the word unsaturated hydrocarbons, right?
Yes.
And general formula CnH twice N. Am I right?
Yep.
You know that N shows the number of carbon, right? This N shows the number of carbon.
Yes.
So
Yep.
as many carbon we will be having, double will be the hydrogen, right?
Yes.
Because the general formula is indicating if N are the number of carbon, twice N will be the number of hydrogen, right?
Yep.
So please keep it in mind that the general formula for alkenes is CnH twice N. Fine.
Yep.
I underlined the word unsaturated hydrocarbons. We will certainly come back to it. Let me introduce you with the functional group. The functional group in alkenes is carbon-carbon double covalent bond.
Yep.
It's fine.
So carbon-carbon double
So
covalent bond.
please remember, in alkenes, we have at least one carbon-carbon double bond,
Yes.
which is the main identity of alkenes. Any structure, if you look at their hydrocarbons, and they have at least one carbon-carbon double bond in the structure, 100% it's alkene, right?
Yep. Yep.
So what is the functional group in alkenes?
Functional group in alkenes is carbon-carbon double covalent bond.
Remember, always use the word carbon-carbon double bond, not the double bond. Only if you will be writing
Yep.
only double bond, it's unacceptable. So whenever it is
We
asked,
need to write it is a double covalent bond of carbon-carbon.
not of, between two carbon atoms, right?
Yes.
So
Between two carbon.
it is a better word to write carbon-carbon double covalent bond, and I mentioned it here as well, right?
Yes.
That's why. In the introduction, we learned that alkenes are a family, alkenes are a group, alkenes are a homologous series of unsaturated hydrocarbons. Here you can think about the word unsaturated. The one word unsaturated reflects the reactivity of alkenes. That alkenes are reactive at RTP. It's quite what I must say that it's quite contrary to alkanes that we learned about alkanes, that alkanes are
Yes.
inert at RTP, right?
Yes. Yep.
Because they were saturated hydrocarbons, they don't have any functional group, right?
Yes.
But
Yep.
here alkenes are defined as unsaturated hydrocarbons, right?
Yes. Yes.
It means they are reactive at room temperature pressure, and
Yes.
they are the compounds of carbon and hydrogen only. Am I right?
Yep.
This is the simple meanings of unsaturated, simple meanings. But technically, as per the Cambridge specification, please remember, as per the Cambridge specification, keep it in mind, what does the unsaturated means as per the Cambridge specification?
Yes.
Unsaturation, yeah, unsaturated means something which is having at least one or more carbon carbon double bonds. Please remember, the unsaturation, word unsaturation, it represents, it reflects that this structure, this compound, this molecule has one or more carbon carbon double bonds, right?
Yes. Yep.
Any confusion?
No.
So please define alkenes again for me. How
Okay.
I defined the alkene?
What alkenes are a homologous series of unsaturated hydrocarbons with general formula CnH2n.
Okay,
And when we say unsaturated,
please wait. When I'm saying wait, it means wait. Thank you.
yes,
What do you understand by the word unsaturated?
the word unsaturated tells us that they are reactive at RTP
And
and they have a carbon and hydrogen only.
what I told you, according to Cambridge specification, what examiner looks for about unsaturation?
That they need to have more than one carbon-carbon double bond, one or more carbon-carbon double bonds.
Please stick to this answer. Stick to this
Yes,
answer. Whenever
yes,
you are asked, what do you mean by the word unsaturated? It means a molecule which contains one or more carbon carbon double bonds. That's it.
yes,
Am
yep,
I right?
yes,
Okay. Now, this carbon carbon double bond, which I told you, it is the functional group of alkenes. It makes alkenes unsaturated, right?
yep,
It makes alkenes reactive, right?
yes,
So please remember, carbon carbon double covalent bond, which is the functional group of alkenes, it makes alkenes unsaturated, right?
yes,
It
yep,
it enables alkenes to react at room temperature pressure, right?
yes,
And we will certainly look into the detail when we will go through the chemical reactions of alkenes. You will see that how this carbon carbon double bond is enabling alkenes to react at
yes,
RTP, right?
yep,
Okay. Test for alkenes, test for unsaturation, test for carbon carbon double bond. They all are similar commands.
yes,
Test for carbon carbon double bond, test for unsaturation, test for alkene functional group. They all are
yes,
similar commands, right?
yes. And it is the bromine water test.
Absolutely right. That whenever you are given some compound in the lab to confirm
Yes,
whether this compound is having carbon carbon double bond or not,
yes,
so you need to react that compound with bromine water or aqueous bromine, you can
yes,
call it, right?
yep. And it will turn from brown water to
It will
uh,
turn from
it
red brown to colorless, right?
yes, red brown to colors.
Or you can say that the red brown color of aqueous bromine fades, fine.
Yes, yes,
Or you can write that the orange color, examiner also accepts the
yeah,
orange color, the orange color of bromine water fades.
yes, yes, yep,
So if a molecule, if a compound with carbon carbon double bond, if it reacts with
yes.
bromine water, what it will
And
do
it
with the
turns
bromine
colorless.
water? What it will do with the
Will
bromine
turn
water?
bromine water turns red to colorless.
Red brown to colorless, right?
Yes. Red, brown to colorless.
Or you can also write orange to colorless. This is also acceptable.
Yes.
Let
Yep.
me mention it. Or you can write it orange to colorless.
Yep.
Okay, dear?
Yes.
Any confusion?
No. So
Sure you.
basically the test for carbon-carbon double bond is unsaturation test. Basically the test tells us that we need to add bromine water, and if the bromine water turns red-brown to colorless, then the alkene is present.
Absolutely. It's a
It's
positive
unsaturated.
test. It's a positive test for unsaturation.
Yes.
It proves that the compound is unsaturated. It proves that
Yep.
compound contains one or more carbon-carbon double bond.
Yeah.
It proves that
Yep.
the compound contains alkene functional group, which is carbon-carbon double bond. Right?
Yes. Yep.
I hope you're getting my point.
Yes.
That's correct. Should we move ahead now?
Yes.
Okay. Now, heading towards the next learning objective, that is naming alkenes, right?
Yes.
How the alkenes are named. Alkenes are named first by writing the prefix, and prefix shows the number of carbon. Eth,
Yep.
prop, bute, pent, like that. They all are prefixes,
Yeah.
right?
Yep.
And these prefixes will show the number of carbon atoms in the parent chain.
Yes.
And after the prefix, we will use the suffix en,
Yes.
and this suffix en shows that the compound is alkene, right?
Yep. Yep.
Let's see how to do it. Now we are starting with naming alkenes, right? How the alkenes are
Yep.
named. Okay, dear. Let's begin with naming alkenes. I'm going to make a few structures for you, and then we will name it together. Let's make the structure number one. This is the first member of alkene homologous series,
Yes. Which is
which is
ethene.
absolutely right. That's great, mashallah. Very nice. And what is
Yep.
the molecular formula of this compound?
C2H4.
Absolutely. And you can see that
Yes.
C2H4, C2H4 is in accordance with the general formula for alkenes.
Yes.
It is obeying the general formula for alkenes, which is
Yes.
CnH2n. Am I right?
Yes. Yep.
You can see as many carbon, double the hydrogen. Fine. Is this okay, beta?
Yes. Yep.
So the name is ethene. Eth means two carbon, en means alkene. It's a two carbon atom alkene.
Yes.
Let's move to the
Yep.
next one. Let's move to the next one. And we must take care that every carbon atom must have four bonds, not more than four bonds, right?
Oh. Yep.
While making the structures. Is this fine, dear?
Yes.
Okay. How many carbon atoms this parent chain is having?
This one has 3.
So what will be the prefix?
Prop.
Absolutely
Propene.
right. Absolutely. And the suffix will be
Ene.
in. It makes the propene. And please let me know about the molecular formula of propene, Peter.
Molecular formula of propene is C3H6.
Oh, that's nice. That's right. So let me write it for you, C3H6. And again, you can see C3H6 is obeying the general formula for alkenes, that is CnH twice N. That
Yep.
as many carbon, double the hydrogen, right?
Yes.